everybody, I thought I would make a video on a couple of the really weird domain type questions. So I want to compare this f of x and this g of x. So the first thing we notice, well, we can take the square root of 0, but we can't take the square root of a negative. So what I like to do on these particular problems is I would set them equal to 0. And then this gives us x squared is equal to 9, square root, plus minus. I find that x is equal to plus or minus 3. And then what I'm going to do is I'm going to make what my IB class would call a sign diagram. And so I'm going to put -3 and +3 on a number line. And then I want to find the values that make this statement work. Okay, so if I plug in 0, for example, then I would have, so like f of 0 would be equal to the square root of 0 minus 9, or the square root of -9, and that's non-real. So what happens here is that this value is not part of my domain. So we can equal these values, so I can close those circles. And then the part in between -3 and +3 isn't going to work, as we just checked with 0. We can also check with, say, f of -4. And if I do something like that, now -4 squared minus 9, a negative squared becomes a positive, so that's 16 minus 9. The square root of, what, 16 minus 9 is 7. It's not a pretty number, but it's a real number, so we're good. So what's going to happen is that we're going to end up with this scenario where it's anything smaller than -3 or bigger than +3. So on this one, we would say that its domain goes from -infinity to -3, pick it up again from 3 and go to infinity. Now, g of x is a very similar sort of scenario, but I've switched things around. We know that if we plug in 3 or -3, well, okay, 9 minus x squared is equal to 0, then I can say, well, 9 is equal to x squared. Therefore, x would have to equal, once again, square root, plus or minus 3. But on this one, when I come to do my little sign diagram or put this on the number line, I can have both of those values. But now when I plug in something between that interval, so say g of 0, this becomes the square root of 9 minus 0. Well, that's the square root of 9, which is very obviously 3. And so that's a real number. That works for us. So what we're going to have in this case is we're going to have that part of the number line. If I tried 4, say g of 4, this would be equal to the square root of 9 minus 16, which is the square root of -7, which is non-real. Okay, so that's not going to work for us. So, well, we can't, there are no values to graph when y is equal to square root of -7. So we don't really care about that part. Or that x value is not in our domain. So here, our domain for that particular problem is going to be from -3 to +3. Let me make a point here. If I have a function and it's the nth root of, I don't really care. If it's an even root, it's going to start looking something like this. So if you were to go to graph y is equal to the square root of x versus y is equal to the 4th root of x, or y is equal to the 6th root of x, they're not the same graph. But they have the same basic shape, and they have exactly the same domain, which is going to go from 0 to infinity before I do any sort of transformations. I think, oh, I do have Desmos open. If you notice, I can say x to the 1/2 versus x to the 1/4 versus x raised to the 1/6. Okay, they're not the same, obviously, but they do have a similar shape and the same domain. Coming back, so whenever n right here is even, it has a restricted domain. But what happens when x is, or when that n value is odd? Maybe I should say it's even and n is not equal to 0. I don't know that we talk about. Oh, well, I mean, we could. No, we can't. Sorry. I can have a to the 0 power, but I can't have a to the 1 over 0 because that's undefined. So it's a non-zero even. It's a positive even integer. Let's go with that. Okay. So if I have where this is y is equal to the cube root of x, with this, what happens here is that, well, quick little reminder, negative 2 cubed is a negative 2 times a negative 2 times a negative 2. 3 negatives gives me a negative, and that's negative 8. So another way to think, well, what happens here is, say we've got f of x is equal to the cube root of x. If I try f of negative 8, I'm taking the cube root of negative 8. Well, that's equal to negative 2. So those odd values, they give us a graph that looks something like that. Okay, so the cube root would look something like this. The fifth root is not the same graph, just like we saw a minute ago with the even powers, but it has this same, pretend I can draw, this same basic shape. So hopefully that was helpful. We'll go over any questions if you have them.